Now, to understand the Singleton design pattern, we need to understand the static keyword, and we need to understand it quite profoundly so. So if you're already familiar with the static keyword, you can feel free to skip this video. However, if you're not completely sure, I would encourage you to watch it. So what is the static keyword? Static means that a variable or method is not relating to the instance, but instead relating to the class. Well, that's strange and it's hard to get what it means, but let me just span this a little further and you're going to get it right away, okay? So I'll come back to this right away. First, let's look what we can use this on. So we can use it on variables, methods, and classes. And we're going to look at each one of these and look what this keyword does with this with a variable, method, or class. Now, first off, static variables can be declared like this. So instead of just having an integer x equals 5, we just say it's a static integer. And this changes a little bit in the background. So this variable is now shared between all instances of the class. It's not stored in each instance, it's shared between all of these instances. That's a huge difference. And you need to be careful because you can wreck your program if you do it wrong. You can also have behavior that's not that easy to detect if you're not careful. So you really need to get this concept. So you can imagine it like this. The variable is stored in the class, not in the instance. And that should sound strange if you're familiar with object-oriented programming, because classes are very abstract concepts that don't really exist in our runtime, okay? The only thing that usually exists are instances. But if you use the static keyword on a variable, you can imagine it like it's stored in the class. That's why it's shared between all instances, okay? All right, so be warned. If you change this variable now, it changes for every instance of this class. That's something you need to be aware of. But it's also something that enables us to easily access the Singleton class. Okay, so now let's look at the static keyword in a little more abstract and visual way. Do mind, this is something to help you imagine what's going on. In the RAM, it won't look like this, okay? It will be a little bit different. So this is just something that helps you visualize how the static keyword affects variables. Now, first off, we have this class level, okay? And then we have instance level. And you'll see what I mean by that right away. So I have this class, and it says it has a static max HP variable of the type integer. So what this would do in our code is it would give us give the class enemy a max HP of 10. Do mind, this variable is stored in the class, as I said before. Next up, we have current HP. And this current HP equals 5 means that each enemy instance gets one of these variables. So do mind, here is no static keyword, here is the static keyword. And that's the difference between those two. Static means it's shared, it's stored in the class, it's shared between all three enemies. No static means every instance has its own variable. Okay, so far so good. Now we have a method that's called setMaxHP, and you can give it a parameter and it sets just the current HP and the max HP to this value. So let's look what's going to happen. Imagine that somewhere this code is called enemy1.setMaxHP to 50. So it should set the current HP to 50 and then also the max HP, okay? Because it's also healed to full, I guess, if you change the max HP. Whatever, yeah, we roll with it. It's like this in this program. Now, let's look at this, this line. First, it sets the current HP to the new value. So current HP is now 50. Next, max HP is set to the value. And max HP is now here also 50. Now I've got an important question. How much max HP does enemy 2 now have? Yeah, you're right. It's 50. So maybe that's not what we wanted. It could be what we wanted, but maybe we just wanted to buff up enemy 1 so it has more HP. But if we use max HP here as a static variable, we buffed all the enemies. At least we buffed their max HP. But the current HP were only changed for enemy 1. Enemy 2 and 3 weren't touched because we only set enemy 1.set max HP. So this is something you have always to be aware of. This can be, like in this case, not what we want. But in many cases, this behavior is very, very useful. And you'll see how useful this is if I show you how we implement exactly this behavior in our Singleton design pattern. To access a static variable, you need to do something a little bit different than with normal variables, because they belong to a class and not to an instance. So we need to set these static variables also via the class. Let me show you what that means. So I have this code. This belongs to the example that we just saw. And we still have the max HP and the current HP variable. And then we have a player, and the player can attack an enemy. And if he attacks him, the enemy should lose HP. Now let's look how we can access these two variables. Now, the instance variable is accessed just normally, as you probably know it. You say e.currentHP minus equals 1. Here, this is a reference to an instance, yeah, from the parameter here. But the static variable works a little bit different. You remember I said static variables live on the class level. So static variables are accessed like this. So here is the important part. We don't access them via the instance because they are not stored in the instance. We access them via the class. And that's something, if you remember when you first learned about object-oriented programming, that's probably a mistake you made quite often. You didn't get the difference between instance and class. And what I see most of the time when students first learn about object-oriented programming, they try to access instance variables like this. But for instance variables, that won't work. But if you use static variables, you can do this. With static variables, they are stored in the class level. That way you can access them. So keep that in mind. This is important if you're going to work with them. If your guts turn around, if you see this and you feel dirty because it's usually not the correct way to do it, just accept it and let it in. We're learning something new. We're expanding our knowledge. We now know this is also possible through static variables. Yeah, that's all there is to know about static variables. Next up, static methods. Static methods work just like in variables. You just put them in front of your method declaration, and that way this variable is not associated with the instance, but rather with the class itself. Now, what does this mean? This method is no longer called on an instance level, but rather on a class level. And this means this restricts the method. It can't access instance variables. It can only access its parameters and static variables or methods. You have no access to instance methods or instance variables. That's something you need to be aware of. And yeah, what does this mean in a practical example? Let's look at it. We have a very simple code. Imagine this is in a class, yeah? We have x equals 5, static x equals 10. This is a static variable. Now we have the static method, and it tries to set x to 50 and tries to set static x to 50. Now, for static variables, this works because they're stored on the class level. But for instance variables, that's not possible because our static variable cannot know which of these 200 instances of my enemy or whatever this is, it should set the x variable. That's why you can't access it, okay? Next up, a small change. We have now a parameter. And if I try to set the x again, it won't work because it's an instance variable. But if it tries to set the static variable to the parameter this method gets, that's possible. That's no problem. Okay? So again, static methods have no access to an instance variable because imagine you have 200 instances of enemies and then you call a static method on the enemy class. If you try to set an instance variable, which one of those 200 enemies should the instance variable then be set? You couldn't possibly know. The only thing you can change here are other static variables or methods. And last up, we have static classes. Static classes, there's not much to say about them. That's just a class that can't be instantiated. So it can only have static variables and methods, and there cannot be an instance of this class. And that's all there is to know about this. Now, static classes are sometimes used to create so-called util classes. This means these are classes that just provide some utility. And usually that's just methods which help you, for example, some mathematical functions. You wouldn't need to instantiate this math class, but you can just use, I don't know, math.calculate shortest distance or something, and that way you can use it. So it's very convenient that you don't need to instantiate this class first. If you just need a method that's very generic. Yeah, that's everything there is to know about static classes. Now, if you enjoyed this video, I want to invite you to my course over at Udemy. This course is solely devoted to design patterns in Unity, and there you will gain access to premium quality exercises and examples for these design patterns. Also, I will talk about more specialized and more advanced implementations of these design patterns. So if you press on the link in the description below, you will get a discount on the course. Anyways, I'll see you in the next video.